All right, so this is where. Look, I already forgot which way to point. This is where we are. What is possible? Philosophical approaches to mathematics education research. And I am an assistant professor at East Stroudsburg University of Pennsylvania. If you want to reach me afterwards, my email is cdubs@esu.edu. And a little bit about me. So I got my PhD from Michigan State University, the program in mathematics education. I saw a couple folks in the participant list from Prime, so welcome, folks. And I graduated actually May of 2020. So I finished my dissertation during coronavirus and the pandemic. And it was just a very weird time to dissertate, a weird time to defend. No graduation, things like that. But thankfully, I was able to get a job before all of the contraction and closures happened. And so I'm an assistant professor in the Department of Mathematics at ESU. And my cat wants to be part of the talk, and so he's in here now next to me. I'm also on Twitter, so at dubschr is a good place to find me, Jasper. And that's my professional social media. So something that started all of this. So I was in a humanities-oriented approach to education research class, and so I was very thankful to have a class like that at Michigan State. But we were learning about history and historiography, and I asked, if history is the study of what has been in mathematics education, what's the study of what can be, right? So if history is looking back, how do we look forward? And Lynn Fendler, my professor there, said philosophy. And so at that point, I was like, all right, I'm hooked. So a little bit about what we're going to talk about today. So I'm going to go through some orientations. I'm going to kind of introduce you to my style of philosophical approaches to math ed research, which is really this critical interrogation of the terms, the language, these things that we kind of take for granted. So we're going to look at the word mathematician and kind of what that means, particularly in terms of what that means in terms of inequality. We're going to look at ethics and what we mean by when we say the word ethics or ethical. And then we're going to zoom out biggest picture. What do we mean when we talk about math ed research? And so what is it that we mean when we say math ed research? What is that thing? So I'm going to start here with a quote from Foucault. And so in a couple slides from now, you'll see that this is one of the big three most influential forces in my thought. But Foucault says that my role is to show people that they're freer than they feel. That things that people accept as truth really have been built up in a certain period of time, and that evidence can be criticized and destroyed. So things that we assume, things that we take for granted, often really are contingent and dependent on the context that we're in. And it turns out that when we kind of point at those foundations, these things that seem so obvious and evident kind of fall apart. And so that really informs my role, which is to perturb or kind of change, influence slightly what we as math ed researchers can see, say, think, and do in the name of math ed research. And so I'm not going to give you a definition, this is math ed research, but I'm going to suggest that we as a field and our work can redefine it, that we can change what we think of when we think of math ed research. And so some orientations. I think when we learn about research, we often get told about quantitative research on one side, qualitative research on the other, and then this space in the middle called mixed methods, which kind of take bits and pieces of both. But that doesn't quite paint the whole picture. So remember, freer than we think. It turns out that both of these, and mixed methods together, are empirical research, and that excludes this entire tradition of humanities-oriented research. And so these are studies in the history of education, the philosophy of education, literary theory and analyses, linguistics, and even arts. So arts-based education research is a large field, or kind of large, relatively speaking, is a well-documented and theorized kind of approach to research. And so this isn't something that I've come up with. AERA has the standards for reporting on humanities-oriented research, because things like method, theoretical framework, data, analysis, implications, conclusions, while often proposed as the way to present empirical research, doesn't really work for humanities oriented research. And so, what we need is kind of another way to look at those. So, if you want to do this type of work and people are like, that's not real research, you point to this document and you're like, actually, AERA says that it's stuff, and there are some guidelines on how to report it. And so, philosophy is really what I'm going to focus on here today. And so within math education and math ed research, Paul Ernest is kind of the go-to name, the name that a lot of people will think of. I mean, there are others, David Stinson, Ole Skosmose, Ubertan de Brogio, things like that. And so there are other names that associated with, I think, Paul Ernest, because he literally wrote the book, The Philosophy of Mathematics Education, is this one that comes to mind. And so he's like, so part of the picture is the philosophy of math. So what is math? How can we talk about its nature? Is it this Platonic ideal that lives out there and we're just discovering math? Or is it the result of human action? And then he's also like, well, what philosophies of math have been developed? Whose are they? But that's only part of the picture, right? So philosophy of math ed is not only philosophies of mathematics. And notice I switched to plural here, because it's not just a single philosophy of math. It's philosophies, but they're also philosophies of education. So what's the nature of education? What are its goals? And those sorts of things. Philosophies of learning and knowing, and philosophies of teaching. But I think that really philosophy of math ed is bigger than the sum of these four parts, because philosophy doesn't have a single meaning. So under this umbrella of philosophy is aesthetics. So things that we see and the sensory experience, the things that are pleasing to the eye, pleasing to the mind, and things like that. Epistemology. What do we know? How do we know things? What's the nature of knowledge and knowing? Ethics. So how do we describe the kind of proper conduct? What should we do? We have lots of things that we can do, but what things should we do? And so that's really where ethics comes in. And then ontology, the nature of being. So what is mathematics education? Is it this thing, kind of going back to Plato and his these Platonic ideals? Is math ed this ideal that exists out there and we're just trying to approximate it or enact it? Or is it this social experiment, this social kind of interaction and engagement? And so I could spend an entire time talking about each of those things. So if you're interested, look those things up. You're going to find names like Natalie Sinclair for aesthetics of mathematics education, ethics. There are a number of people. So I have a piece, and then Skov-Mose has a piece, and Boyland has a piece. So we'll talk about those. Ontology, I think, if that's something you're interested in, is relatively nascent in the field. And epistemology, folks have been arguing about what it means to know math for about as long as math's been around, so that one's also well established. So where does this work take place? So one journal that immediately comes to mind is the Philosophy of Math Ed journal. And so, like I said, David Stinson's a name I think of, Ole Skov-Mose, Paul Ernest, who wrote the book, is the editor of this journal. And then there are lots of things. So if you're interested in this, I would say poke around on the website. I have the link here, and I'll share the PowerPoint with everybody at the end. And so that's a really good place to start, just see what people are talking about in the philosophy of mathematics education. I will say that there are some pop-ups on his website sometimes, so just close those if those pop up. And then, again, if history is looking back, philosophy looking forward. Coming in fall of 2022, the Journal for Theoretical and Marginal Mathematics Education is really going to have an interest and focus on philosophy of mathematics education. Shameless plug, I'm on the editorial board for this journal, so I think just getting knowledge out there and thinking, all right, if this is the type of work you undertake, there will be another avenue. But JRME doesn't necessarily exclude it. Journal Verb and Math Ed doesn't necessarily exclude it. FLM is a particularly good venue for philosophy pieces. ESM, ZDM, I think are less philosophy focused, but certainly appropriate avenues too. So, like I said, philosophy for me really is about interrogating these things we take for granted. So, what do you call the people in a math classroom? So, there's somebody perhaps at the computer or at the chalkboard, and we call them something. Maybe we call them the teacher, the professor, whatever. And then there are other people in this space sitting at desks or tables. You might call them students, you might call them learners, but I might argue that you might call them mathematicians. And so, learner, student, or mathematician. So Rancière is one of these other big names that's really influenced my thought. And so for Rancière, who really is a philosopher of equality, he says if we say equality is this thing that we're going to get to, that we're going to reach, someday we're going to reach equality, he says that's to hand it over to the pedagogues of progress. They're going to say, we're here, equality's there, and there's all this stuff in between. And then you're going to make progress where they'll be like, oh, but there's still all this space between. And so there's always going to be this gap, this distance. And so for Rancière, he says, equality is a presupposition, an initial axiom, or it's nothing. So for Rancière, equality is something that we do in the human-to-human interaction, right here and now. We don't reach equality later, we enact equality now. So this comes from this book, The Ignorant Schoolmaster, so I highly recommend you check out this book. If you Google it, you might find a PDF. But I highly, highly recommend this book because I think of all the things I read in graduate school, this single-handedly, completely flipped my understanding of teaching and learning. And that's a big claim, but I think it'll hold up. And so when we talk about equality, when we call someone a learner, we're defining them by what they don't know. The lack of knowledge that they need to learn. When we call them a student, well, we're still able to now we recognize that they can study, that they can learn, but they still don't know, right? There's teacher and student, this kind of dichotomy, and I'm the teacher because I'm not a student. But mathematician might be a solution to this. And I say might be because we'll get there. So if we look back, so I'm always doing this looking back to look forward thing. If we look back to the ancient Greek, mathematikos was used to describe two groups of people. So first, these advanced students of Pythagoras who fully understood all of his works, all of his talks, all of his ideas. But then Aristotle used mathematikos to refer to anyone that knows and does mathematics. And so we can see this kind of different use of mathematician then, but we can also see it today, right? So when I first was exploring these ideas, the first response I got was, well, what about the research mathematicians, those with PhDs? How do we refer to them and distinguish them from, if we say everyone's a mathematician, the children in our classroom? And so thinking of Rancière and equality being something we do in the here and now, I said, well, why do you want that distinction? Why do we need to assert this inequality? Why are you so interested in asserting this difference? And they have lots of things to say to that. But my point is that I want to trouble the assumption that the relationship between teacher and student is necessarily defined by an inequality. If we call the children in our classroom, and so I often work with future K-8 teachers, and so I still think of them as children, as their future students. But mathematician, if we call those children or those students or the people in our classroom mathematicians, we're asserting an equality. And so for this, I surveyed a bunch of articles. I looked at all of those published since 2010 in Jeremy, FLM, and ESM. There are 165 of those articles that use the term learner, student, or mathematician in the title or abstract. The breakdown's here. But my interest is here, is so how do we as a field use the term mathematician, right? Because I want to know, is anyone using mathematician in this way that enacts equality. And so 11 of those 14 instances used it in this exclusive Pythagorean sense. And so the references are here if you want to go look them up. But they were talking about mathematicians who are graduate students or research PhDs. And that's what they mean by they say mathematician. But there are 3 examples that use mathematician in this broader Aristotelian sense. So the first, by Radovic and colleagues, is they refer mathematician to these girls in secondary school that have developed positive mathematics identities. So there's something about this identifying with mathematics for them that justifies being a mathematician. In Shrieky's article, they're talking about a mathematician formulates new concepts, raises conjectures, and proves or refutes them. Well, I think if you've been in a math class, you know that raising conjectures and proving and refuting them is kind of something that we all do, right? All of us are doing that. And if you've ever worked with mathematicians in your classroom, you know that they come up with new ideas all the time. They say, well, what if we do this to these shapes? Or what if we change this, right? And so really this is this more general, inclusive knower and doer. But then this last one by Gadanidis takes this explicit anti-deficit stance, and he's talking about children in early elementary school. And he says that these producers of mathematical knowledge are mathematicians. And he actually flips it and he says, let's not worry about whether or not we're calling them mathematicians, but let's worry about whether or not this math is worthy of these children and their mathematical potential, right? And so he's like, there's maybe an inequality, but it's actually reversed. Is the mathematics we're teaching worthy of the children in our spaces? And so really this Aristotelian notion is the one that I prefer. It says, anyone that does mathematics, that demonstrates mathematical thought and practice, can be understood as a mathematician. Not that they will someday become one, they always already are mathematicians. And so this quote that I have from Aristotle is that even a child can be a mathematician. And so this is this first question of, what do we refer to the people in our classrooms? Let's not just assume that the student or learner are these neutral bits of language, but rather really are meaningful and really kind of unpack what that means in terms of inequality. And so that's our first example. And now we'll turn to our second example. Is teaching mathematics ethical? And so if you've ever read or heard of any research by Fauché, he writes about the violence of mathematics and how his mother, who was Palestinian, does this amazing mathematics as a seamstress. But mathematics, capital M, the school mathematics, comes in and says that's not math. That isn't important. And so if we think of math in that way as really limiting who can know, is it even ethical to teach mathematics? And I think the answer to that depends on how you define ethics. And so whose ethics are we talking about? Because ethics isn't this thing that exists out there. It's an idea that somebody has put into words. So the idea for this kind of idea started with this piece by Paul Ernest, right? He's a popular name. From FLM. It's called What is Our First Philosophy in Mathematics Education? And so he's making this argument and he's like, what is this thing that really undergirds everything we do? How do we justify what it is that we do as math ed researchers? And so he looks at, is it ontology? Is it being? Is it epistemology or knowing? Is it ethics or proper conduct or critical theory? What is the thing? And so for Ernest, he concludes that ethics is the first philosophy. Ethics, and our ethical responsibility for educating students, is that which holds the project of math ed research together. Everything we do, Ernest argues, can be traced back to an ethical justification for why we do it. And he says, like, epistemology or knowing isn't enough because we care about, like, social interaction. And that's more than just knowing things. And so, like, those are the sorts of arguments he's making. And so I continue this argument. I think that ethics really can be a first philosophy of mathematics education research. But ethics isn't a monolithic concept. There isn't a single meaning when we say ethics. Within ethics, and we'll talk about some of these approaches, is there are competing approaches, and there are ethical perspectives that are incommensurable, that you can't bring together in harmony, that will necessarily conflict. And so we'll talk about virtue, duty, and utilitarian ethics being these kind of normative branches, and then some postmodern approaches. And so my question for this, and this actually comes from my depth paper. So we had to write these sets of written examinations to become doctoral candidates. And this was my depth paper. So I wanted to know, how have theories of ethics been applied to math ed research? And what alternatives haven't been considered? So what might be the implications be if these alternate formulations come in? So the first question says, let's look at math ed research and let's see how people have talked about ethics. And then the second piece says, well, let's look at philosophy and people that publish in philosophy writ large. How have they defined philosophy or ethics? And what would then happen if we dropped those in to math ed research? So I did a lit review. I had, if you want details of the search, it's in the paper. But I did an ERIC search. And so we look for ethics in math ed. And it turns out that there are about 6 big ways that ethics have been taken up. So first is an ethic of care. And so that's ethic, and this comes from Nell Nodding's work. And then we have ethic of critique. And so this comes from a number of folks, but really I think Scov-Mose is kind of this big name in terms of ethic of critique. And so if ethic of care is the right thing is the thing that cares for others. So teaching is caring. Teaching is this thing. Ethic of critique. So we do the things that help us to think critically. And so math helps us critique our world. Therefore, we should teach it. It turns out that Dewey's work actually kind of thinks of mathematics as an ethics, as this way of looking at the world and determining whether or not we should do certain things. This purple branch by Emmanuel Levinas turns out to be the most widely adopted. And you'll see, right, there are a number of those. And so that's the one we'll talk a little bit more about. Foucaultian ethics, so it's not like Foucault didn't get any attention. Margaret Walshaw, I think, is a big Foucault scholar in math ed. And then indigenous ethics. And so how do indigenous populations conceive of the ethical? And what does that then mean for the field of math ed? So there are kind of these 6 big ways, and many of them haven't had considerable uptake. But this purple branch, this Levinasian ethics, really has. And so I dug into that a little bit. But Hume, and so this was a long time ago, 1739, creates what he calls the is-ought distinction. And so he was David Hume writing in English? Probably. It might have been Latin. But the distinction is, just because things are a certain way, that's not a justification for them oughting to be that way. And I don't think that's the word. But it's this naturalistic fallacy, is what we call it often, is that the state of things isn't justification for what should be. So just because Levinas's perspective is the most widely adopted, that's not a sufficient argument to establish that it ought to be. There's a separate ought argument that needs to say, well, Levinas's perspective is this, and it's better for this, and this reason, and therefore it ought to be the most widely adopted. But it turns out that I think that argument really is missing. And so, again, looking back to look forward, what are alternatives? So, if we don't take those 6 approaches that really are unpacked, Levinas is here because most uptake. But what else can be? And so within normative ethics are virtue ethics, duty ethics, and utilitarian ethics. And I'm going to go under each of these in turn. And then postmodern ethics, Levinas, some will argue falls under this umbrella. I'll argue that he doesn't. But I put him here because that's where Neyland and a number of other folks, that Ernest even, will classify Levinasian ethics. But again, if we look at the philosophy literature, there are a number of folks that make the argument that Levinas is modern and not postmodern. We'll talk about what that means. And then I'll talk about some ethics of Judith Butler, who is probably the 4th most influential in my thinking. So virtue ethics is about the ethical nature of something. So like learning might be a virtue, or care might be a virtue. Like some things are just inherently good. And so if we approached math ed from a virtue ethicist perspective, we might argue, is math education itself virtuous? Or if it isn't itself, what are the virtues? Maybe critical thinking, maybe being empowered in society, right? Maybe there are some things that are just good, and that's why we should teach mathematics. Maybe teaching itself is a virtue. Sharing knowledge maybe just is inherently good. Or maybe having mathematical knowledge is inherently good, right? And so we might argue that some things are inherently good, and those justify why we do certain things. Now, in contrast to things being just inherently good, duty ethics, or deontological is the fancy philosophy word for that, wonders if there are things that are duties and rights or contractual obligations. And so the go-to for this is Immanuel Kant had this categorical imperative. That was, you would want others to act, or you should act the way you would want others to act, right? If you wouldn't want someone to wish harm on you, you shouldn't wish harm on them. And so that's kind of this contractual obligation to a well-structured society. And so you might ask, is it the duty of those that know math, so us as math ed researchers, is it our duty to pass on this knowledge so that it's not lost from one generation to another? Is it our duty to teach math because it enables people to understand and change their world? Is maybe learning and knowing math is a right? And I think Bob Moses would argue that knowing math, knowing algebra is a right. Therefore, we should teach math. Or because of the power and status that people get because they're smart at math. Maybe we owe that to students, and so it's our obligation to teach math. And you're going to learn that I ask more questions than I answer. That's maybe another philosophy thing. So maybe it's our obligation to teach. Now, utilitarians would argue things are right, actions are right, if and only if, so bringing in some of our logic as mathematicians we want to do. If the total amount of good that comes out of an act exceeds the total amount of bad, then that's the right thing to do. And so a utilitarian response to Fauché's mathematical violence and his mother's math being erased would be, well, it helps more people than it hurts. Right? And you can see how that already starts to feel like a little slippery slope of if it helps more people than it hurts, then it's justified. And there are lots of counters to utilitarian ethics that I won't go into. But it would say, is math ed justified because overall there's more happiness than harm? Is the overall benefit outweighing any of the harm it inflicts? So on average, does math make people happier? Does it help people more? Or since it seeks to educate all, and since maybe you might construe that those most vulnerable can benefit from learning math, we're justified in teaching. And so I'm not going to endorse any one of these approaches because my interest is in, as you'll see in my third example, is in broadening perspectives. So these are questions that I don't think are answered in the literature. Now, postmodern ethics. So all of those approaches up to this point, whether something being inherently good, something being our duty or obligation, or maximizing the good and minimizing the bad, all of those give us a norm, an idea that we should enact. We can just apply that in every situation. Is this creating more harm than good? Check, okay, do that thing. Or is this thing inherently good? Okay, keep doing it. But when Descartes, right, this was when modernism, kind of the start of modernism, if you will, he said, I think, therefore I am. And so this is where this mind-body split happens, is that my thoughts, my things up here, are separate from the body that I live in, right? We're somehow separate. And so Levinas argued, and so Descartes was an ontologist, or an ethicist? No, empiricist. No, that's not the word. What's the word? It starts with an E. Whatever. The word is eluding me. So Descartes was all about what we know. Epistemologist is the word. Because I think and know, I am. And then there's the joke that says, would you like this? And he's like, I think not. And he poofs away. Because he's not thinking. But for Levinas, he's like, no, that's not the way it is. It's not that I think, therefore I am. It's that I'm ethically responsible. Therefore I think and I am. So before I'm consciously aware of this interaction between me and a person in front of me, or before I enter a classroom and even think about the idea of teaching, I'm already ethically responsible for those future mathematicians in my classroom. And so for him, ethics is that thing that precedes everything. And so in Ernest's piece, he follows this argument. And he says, because the ethics, this ethical recognition for the other, are Levinas's words, this ethical perspective for the other precedes everything. Precedes my conscious awareness, precedes my body being in this space, precedes my knowing, my conscious awareness, all of these things. Ethics is first. And that's also why I would argue that he's not postmodern, because there's a part of us then that precedes our body. So somehow some part of us is still separate. It's in front of, it's before our body. And so contrast that with the work of Judith Butler, who would say the ethical occurs concurrently with being, not prior to it. So it's not I'm ethically responsible, therefore I think and I am, but rather I am ethically responsible and I think and I am. Right? So everything's happening at the same time. Yeah, it's messy. But that also kind of points to how messy ethics are, right? We're already entangled in these ethical relationships before we're thinking about them, just by our very nature of being alive on this planet. And so that's maybe closest to my personal thinking on ethics, is that all of this kind of happens concurrently. But again, my goal isn't to convince you that you should all go and uptake a Butlerian perspective on ethics and method research, although if anyone wants to, please do. But to say, when we think of alternatives, we can imagine different futures. We can ask different questions, and we can imagine something different. And this really, to me, feels like a very natural thing for mathematicians. Because I think about the example of the parallel postulate, and if this is not stuff you're interested in, you can just glaze over for a moment. But we think about, if we use the parallel postulate, which we can't prove, but we assume is true, we can show that the sum of the angles in a triangle is 180 degrees. But that's only when we're working in Euclidean geometry, right? As soon as we move to the surface of the sphere, we no longer have 180 degrees, right? We get larger than 180, right? Because we can somehow have a triangle with 290 degrees that on the surface of a sphere goes on. So I think mathematicians are really good at saying, if this, then what happens? And so for me, philosophy is a lot like that. So if I consider a different ethical perspective, what then are the results from method research? And so that's kind of this bit that I get from this ethics piece. And so this is an aside. We're not going to watch this video of me. But this journal, the Journal of Philosophy of Ed, does video abstracts, which is like the coolest thing ever because I watch way more YouTube than I watch anything else. And so know that some journals offer this. And so keep an eye out if that's something that interests you. And if they don't, you can still make a YouTube video about your paper. Because it turns out I got way more views on this video and tweets about this video than any tweets just about the paper. So videos catch people's attention. Also, if you want all of the nitty-gritty details in like a little 5-minute blurb, you can go watch that. The link's there. I'll share the PowerPoint later. But know that this is a thing. So again, what's possible in research? So not just empirical, it can be humanities oriented, and it doesn't have to be written. It can be video, right? It also feels a lot more natural to talk about our research. All right, so I was going to try to start, and I'll skip there. So my last example that I want to unpack is, what is mathematics education research? What is it that we're talking about when we talk about math ed research? So this turns to Mathematics Education Atlas. And so this is my website, mathedatlas.org. And we really started with this history of let me back up. When I started grad school, they said, you need to figure out the ongoing conversations, what it is that we're talking about as a field. And then once we do that, you need to join that ongoing conversation. Now, I wanted to start some work in queer theory and math ed, and that meant there were like literally 2 other people talking about this. And so for me, needing to connect to the ongoing conversation felt like a limitation, because I wanted to talk about something that few other people were talking about, and honestly, nobody was really listening to us. Since then, somehow, in the past 5 years, I think this really has gotten a lot more attention, and I don't think it's as dire. But I felt frustrated as a graduate student because I didn't know what the ongoing conversations were. And it was like, well, how do you know? And they're like, well, you read things and you figure it out. And I was like, well, that seems really inefficient. And I like efficiency. So to get me to this atlas, and I'll tell you why it's atlas in a slide or two, there were 3 things that really pushed my thinking. So the first was Jacques Rancière's book, The Politics of Aesthetics. Remember, he was the ignorant schoolmaster author. But this, he's talking about what counts as art. And you're like, well, that's fine. What counts as art? No, anything. And so I was like, well, then what counts as math ed research? My answer is also anything. And then Peter Sloterdijk is a German philosopher. This Bubbles, Globes, and Foams trilogy is like 2,600 pages. So like it's an investment. It's also really hard to find right now because the publisher's having demand issues. And then the last is Foucault. And so Lynn Fendler, I highly recommend this book. It's just called Michel Foucault. It's from this Bloomsbury Library of Educational Thought. Lynn, who, disclaimer, was one of my professors, was on my guidance committee and my dissertation committee. She goes through and summarizes all of Foucault's books. She kind of breaks it down into his big ideas and really gives you a snapshot, because people complain constantly that Foucault is so hard to understand. I actually think the longer you read him, I mean, that's probably not a surprise. The more you read of Foucault, I would actually say the more predictable he gets, because he's going to say, you're saying it's this way. Actually, if we look at the details that all of your assumptions are based on, the opposite is true. And so that's this, we're freer than we think. So my question was, or kind of, what is math ed research, right? This is this question. What is it? Whenever we talk about math ed research, it's the output of a bunch of people doing math ed research, right? Like, it doesn't exist out there. There's not like a building called math ed research and we like commute to it. It's just something that's built up by our publications. And within that math ed research, because there are researchers, people doing it, embedded in that is a belonging. So who are the researchers whose ideas are included? Who are the people whose research is heard? And whose fantasy becomes part of the common world? And so this goes back to a Rancière quote from The Politics of Aesthetics. But it says, so whose ideas become part of the cocktail party, right? Because there are lots of ideas that people tend to publish outside of math ed journals. There are lots of people who are trying to do new things and they don't ever really get any sort of breakthrough. And so the question is, what are we talking about and whose ideas are excluded? So to get me to unpack the answer to that question, I want to talk about metaphors for a little bit. So you've often probably heard, like, if I have seen this far, it's only by standing on the shoulders of giants. That knowledge is progressive. It accumulates, and then this is a picture of Mount Everest. Like a mountain, this knowledge just accumulates over time. But then I was introduced to this idea of a cocktail party, that in one group you have people talking about algebra, in this other group you have people talking about calculus, and then I'm going to say in this other group you have people talking about philosophy of math ed. Some of these groups might talk to each other, maybe not. But it's this ongoing conversation. And both of these metaphors, to me, felt really hard to change, right? Because if I wanted to change the conversation at a cocktail party, I would have to, like, sit patiently, quietly on the side and, like, listen to the conversation, figure out what's going on, and then, like, wait till I have a hook and be like, oh, on that note, what are your thoughts on this? And I wanted something easier to change, because Foucault says I'm freer than I think. So I thought about, from Sloterdijk, bubbles and foam. And so this is a picture of foam, and all those little dots, right, are bubbles. I love this metaphor of bubbles and foams for the field of math ed research, because from afar, a foam looks pretty solid, right? Like, it looks like a thing that's there. But if you get really close, it turns out that it's just a bunch of tiny bubbles. And those bubbles aren't fixed, they're really volatile. Some of them are popping, some of them are merging, some of them are splitting, right? There's lots of movement, there's lots of change. And I wanted to think about change. So how do we find these bubbles? We're not going to talk about cocktail party conversation groups, but we're going to talk about bubbles and foams. And so my goal in doing this, so why do I care about bubbles and foams? It's because my obsession is with showing that things can change. So I want to show that math ed research hasn't been fixed across time. And I want to show that there's no consensus on what counts as math ed research today. But why? Why do I care if it hasn't been fixed across time, or why there's no consensus today? Well, if I can do that, it's easier to think about math ed research as bubbles and foams. If I can show that it hasn't been a static thing, I can show that it's volatile. And also, I can show then that where we've gotten to isn't this progressive ideal, this totalizing final accomplishment of, we finally reached math ed research. But rather, we can think of the field as the products of conglomerations of blind forces. So there's just a lot of chaos. There's a lot of randomness. There's a lot of potential. And if things are random, it's really easy to think of it being different. So how? How do I do that? So this is a picture. And believe it or not, this is all of the articles published in JRME in the 1970s. And all of their references. And these dots, these nodes, represent articles, book chapters, things like that. and two dots are connected with a line called an edge if one of them cites the other. Then I assign them through some algorithmic work, and so this is actually in my book, which is also on mathedatlas.org. But what we can do is by looking at the field in a literally mathematical way, right? This is graph theory. I'm able to show that there are 18 big ideas that our field talked about in the 70s. And so here's that picture. This is the JRME in the 1970s. And so there's a big focus on Piaget. There's a big focus on computers because that's really starting to come out. There's a really big focus on quantitative research methods. A little bit on like geometry, attitude. This is around Feynman and Sherman's attitude scales. So this is what it looked like in the 70s in the JRME. But then when we go to the 80s, it changes. There's still some Piaget in number one, but now there's really this big interest in sex difference. So the difference between how boys and girls learn, right? It's still very binary, very biological determinism, which we've moved, thankfully, for the most part beyond. But also now Van Healy starts to emerge, right? So we start to see some things like that. There's an agenda for action. So the National Council of Teachers of Math is really starting to push, as a field, what is it that our interest is? But notice some of these are different. Some things went away, some things are new. When we get to the 80s, Van Healy now a little bit more prominent. But then here this really large dot under the 18. I didn't say this. The size of the dot is proportional to the number of times it's cited. So really big dots are cited more. That's NCTM's 1989 standards. Everybody was citing it. But again, new things. So now there's like cognitively guided instruction, which hadn't been around before. There's an interest in multicultural and critical mathematics education. By the time we get to the 2000s, we have even more. We're up to 35. And by the 2010s, we're up to 37. And we get to see some really specific things, like research in undergraduate math ed. There's an entire bubble on girls' identities and mathematics classrooms. Racialized mathematics experiences. Learning disability. Right? Lots of things that we as a field hadn't been talking about before. Equity and social justice gets a bubble, I think, for the first time here. Maybe in the 2000s. But another feature of these maps that I didn't say yet is their location, centrally and marginally, is literally analogous. That's, I don't think, how that's supposed to be said, but embeds the centrality of those ideas in the field. Because the more connected you are to other things, you're going to get pulled to the middle. And if you're not connected to a lot of things, you're going to get pushed to the margins. So like 31 over here, research on research, which is probably where my research falls in. Really on the edges, because nobody's really talking about it. 32, up here, gender and achievement. It's not really as big of a thing as it was in the 70s, because we've moved beyond this connection between gender and achievement. So this accomplishes that first goal, that the field has shifted across time. And so now I've thrown all of those bubbles, all of those nodes together, and I've color-coded by decade. And so you can see the shifting focus of our field across time. So in the 70s, it's really about mathematical development, knowing, arithmetic. But by the time we get to the 2010s, we're interested in mathematics knowledge for teaching and equity, things like that. And so the field hasn't been fixed. And I'm not going to give you the maps for the comparison across JRME, ESM, and FLM. They're on Math at Atlas and in the book. But I'll give you the list. 37 bubbles in JRME in the 2010s, 13 in FLM, and 8 in ESM. So when you look at math ed in different journals, you get a different picture of what math ed is. And so it's really important then, or not important, that wasn't the word I wanted to start that sentence with. So this helps accomplish my second goal. that there isn't consensus today. So if there isn't a single thing that's our proper focus, and if today there's no consensus on what we should be talking about, I certainly think it seems easier to imagine something different. And so, like I said, my goal isn't to say math ed is this thing. My aim is to institute and maintain a politics of aesthetics of math ed research, which is fancy words for I want us to constantly refigure what we can see, say, think, and do in the name of math ed research. And so, what can we do? Well, in the 70s we did one thing, in the 80s we did another, 90s, 2000s, 2010s. But today we don't do the same thing across the board. So we can do new things. We can do different things. We can do citation network analysis of the field if we want to. And so for me, and this is where I'm going to end with my 3 examples, is that philosophy of math ed research is about questioning foundational assumptions that have been taken for granted. So what do we mean when we say learner, student, or mathematician? Or what are we talking about when we talk ethics? But also to critically interrogate the meanings construed by the language we use. So when we talk about math ed research, when we look at these things, what then is our takeaway from it? And so, it's a lot. It's a lot. This is a book and 2 papers, all smashed into one presentation. But it's because I want you to see that there are lots of different ways that we can do this, right? And I'm not the expert. I might be an expert. I know a lot about these specific things. But there are so many ways that we can do philosophy of math ed research, that we can do math ed research, and I think there's space for all of it. That's also why I like that picture I picked for bubbles and foams, because there was part where there weren't bubbles. And so you can just blow your own bubble, right? You can just do this new thing. That doesn't mean it's necessarily easy, right? Because you need to find a journal that'll publish it, or a venue. Maybe skip the journal and go somewhere else. Also, what we hope, the Journal for Marginal and Theoretical Mathematics, hopefully, will address this need of a space to do new things that change the field. And so I have a bit.ly link here because I thought some folks might want some of the papers I talked about. And so Learner, Student, Mathematician from the Philosophy of Math Ed Journal is there. Who's Ethics, my piece from the Journal Philosophy of Ed. My book isn't there, unfortunately. But all of the maps are on the website, so that's mathedatlas.org. It's also available on Amazon, Barnes & Noble, IndieBound, shameless plugs. But I also want you to know that that book was my dissertation. And Learner, Student, Mathematician was a course paper. And Who's Ethics was my depth paper. And so none of the things that we do in that grad school process need to be for their own sake, right? They can have a new life. They can, looking back to move forward, right? We can do something with those things. And so there are the citations. If you go to, it might not be there yet, but that bit.ly link, this PowerPoint should be there too. So you'll have all of these things, all of the links, and all of the book covers in my slides go to the Amazon page. So I'm book obsessed. And so I wanted to make it easy for other people to find books. All right. That was a dump and a half, but thank you for riding through that with me. Twitter, email, both over there. Yes, I pointed the right way.